All right, so today we're going to get into mass-to-mass stoichiometry. So far we've been doing moles to moles, mass to moles, moles to mass. So this is kind of the last kind of thing to get to all the steps. So if we go back to our map of the world, what we're doing is going from here, mass of our given substance to mass of our wanted substance. So we got to go molar mass to get to moles, mole ratio to get to moles of the wanted, and then molar mass to get to mass of the wanted. Okay, so this is a three-step problem. So here's our problem. We're given this equation: lead 2 acetate plus potassium iodide yields potassium acetate plus lead 2 iodide. And the question is, how many grams of lead 2 iodide, which is this, can be produced from reacting 50 grams of potassium iodide with excess lead 2 acetate. So first of all, when it says excess lead 2 acetate, that means that we have more than we need. Excess means you have way more than you need. And so basically we can ignore that in this case because it's not going to affect how much we can produce. So our given is 50 grams of potassium iodide. So 50 grams of the Ki. So you write that down, and then the first step is always to make sure you balance the equation. So if you don't have a balanced equation, then you can't really do this. You can't really do stoichiometry. So balance the equation. Then you write the given. Then we want to go grams to moles. So we need the molar mass of Ki, which I already looked that up, is 166 grams. And that's equal to 1 mole. Okay. So that gets us here to here. Okay, so now we're at moles. Now we need to do the mole ratio. So mole ratio between Ki and lead 2 iodide is 2 to 1, and we want wanted over given. So our wanted is the 1 mole of PbI2, 2 moles Ki. Okay, again, mole ratio is always the wanted over the given. Wanted over given. Okay, so that gets us to moles of our wanted. Now I'm trying to get to the mass, so I need to multiply by the molar mass. So I need the molar mass of my wanted this time, which is in this case the PbI2. And I already looked that one up. It's 461 grams of PbI2. And that's equal to 1 mole of PbI2. Okay, so from here then, we're at grams of what we're wanting. So now we want to do our math. So we multiply across the top, multiply across the bottom, and then divide. So I'll get my calculator here. So I'm going to do 50 on the top, 50 times 461, 23,050, so that's going to be on top, over 166 times 2, so that's 332. So now I divide those two numbers, so 2350 divided by 332. And that gets me 69.4 grams of PbI2. So there's my answer. That's how many grams I can produce. Okay. So to review the steps, number 1 is always to balance the equation. Number 2 is to write down the given. Again, in this case, it was the 50 grams. Number 3, grams to moles. Number 4, mole ratio. 5, moles back to grams. And then 6 is solve. Do the math. Okay? Those are the steps, the 6 steps for these types of the mass-to-mass reactions. Now, also, I'm going to give you kind of a template for how these should look. So your given always goes there. Then this will be 1 mole of your given. 1 mole of the given. And this will be molar mass of the given. Then this one will be mole ratio of the wanted, mole ratio given. And then this will be 1 mole of the wanted, and this will be molar mass of the wanted. Okay? Let me zoom in here. So again, so you're given, then 1 mole of the given over the molar mass of the given, mole ratio wanted over given, then molar mass wanted, 1 mole wanted. Okay, and that will get you the correct answer every time, as long as your molar masses, as long as all the numbers are correct, but that's the correct setup. Okay, I hope this helps. Let me know if you have any questions.